So welcome back to a next set of video. My name is Revi, and today I'll be talking about the Edgeworth box and the equilibrium concept. So far in the previous videos, we've been working with the Edgeworth box, trying to understand more what the Edgeworth box is about. And what I would like to talk next is this idea of an equilibrium concept. So quite often, in this type of questions, you might be asked to find the equilibrium in the economy. And that's where we kind of break in together all the videos so far. So the videos so far have been about consumer theory, and we're looking at um, basically maximizing utility subject to a budget constraint where the prices are given. And in an exchange economy, our goal is to find the price. So the price is not given to us, and we have to find the price. And we also have to find the final allocation given some initial allocation, right? So before we can dive into this, we first need to ask the question, what is an equilibrium? What is an equilibrium? Well, the equilibrium is a set or a pair of prices. Okay, that's one thing. We need a pair of prices. Note, this could also be equivalent to a single relative price. And we'll come back to this idea in a moment, right? But the price of two goods, there will come a ratio from that, which we know from before is the slope of the budget constraint, right? And we're going to need some initial endowments. And then three, we're going to need some final outcome, final allocations. Now, what makes this an equilibrium is if these three things combined together are special enough. What makes these three things an equilibrium is that at such prices, the market clears. At such prices, such endowments, right? The market clears. What do we mean by that? Um, or in other words, demand equal to supply, and everyone is maximizing their utility subject to the prices. Um, both agents maximize utility, right? That's what we're looking. So effectively, we're going to take all those lessons that we learn in utility maximization and use them here. Let me show you how to think about this. So imagine that each square here is representing some units. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So our total endowment for X is 14. Okay. Let's count the other box for Y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. The endowment for Y in this economy is 10. We really don't care what the X and the Y is, but if it helps you, think about food maybe and shelter. Okay. Next, we're going to need some initial allocation. Where shall we put this in allocation? Well, anywhere, right? So let's say I put it here. Let's call this Revi again. Let's call this Ben. So this is my initial allocation. I'm going to call it with I. And what can I tell about the initial allocation? That Revi got 1, 2, 3 pieces. So the endowment for Revi for X is 3. And of course, the endowment for Ben of X is the leftover, which is 11 in this case, because 11 plus 3 makes the 14 here. Um, And my endowment for Y is 1, 2, 3, 4, 5. So endowment for Revi for Y is 5. And Ben must have the remaining bit, which is 5 as well. Um, okay, so we have one of the component of what could potentially make an equilibrium, which is this one. And we have the initial endowments. Okay, but we have no idea what the price is. And we, in fact, we have to discover what this price is. And of course, we cannot make progress. We cannot know how these individuals will trade holding some prices fixed. So we need some utilities. Okay. What shall we make their utilities? Well, let's see. Maybe we can pick some nice utilities. What are some nice utilities? So if I'm an examiner, for example, a nice utility might be something like utility for Revy for X and Y. I'll make them Cobb-Douglas. So let's say X times Y. Okay. And I could do the same for Ben. I'll also make him Cobb-Douglas. And exactly the same. So X times Y. Okay, that's my utility for Ben. Note that I dropped the function of X and Y for utility for Ben. Okay, I could do the same here, or I could just remind you that this is not a multiplication, right? This is simply a little reminder telling you that this function is a function of the X and the Y, versus on the right-hand side here, we have a multiplication of these two. Okay. Um, Okay, so if that's the case, I can go back to my utility maximization. And you might say, but hold on, Revi, you cannot go back because you don't have an income here. Well, I do have an income. My income will be the value of my endowment. And you might say, but hold on one second, you don't have prices. So you don't have an income. You might have endowment. So Revi does have 3 units of X and 5 units of Y, but he doesn't have an income. I don't have any money kind of being floated around. And I'd say you're right. But what I could do is I could write this value of endowment as a function of prices. So I could say the price of X times um, X plus, which in this case I know it's 3. Okay, I have 3 units of X. Yeah, 3 plus price of y times 5. That's my income. That's my M, right? My monetary income. And knowing this, I could come up with a function for the optimal consumption of X given my income, right? So if I had some arbitrary nominal income, that of course will depend on these two prices that I don't know. Then, if you go back to my video on Cobb-Douglas, you should, right? Like a first-class student will immediately recognize that the functional form of X star should already be known to you. They will spend a half of their income on good X. And therefore, it's going to be a half of 3 plus Py over Px times 5. Okay. All I did there is I divided this by P of X, so the P of X and P of X canceled out, so I'm left with a 3, and the Py over P of X, I'm left with that over there. Okay, so I know what X is. This is what what I will demand of X. Okay, and if this is greater than 3, I will be a net demander of X because I have 3. I want to get more than 3. Okay. Um, and if this is less than 3, I'll be a net supplier of 3 because I have 3 units and I would like to supply some and have to have less. So I'm willing to trade with some of them. Now, let's actually talk a little bit about this because I know it will confuse some of you. So let's actually talk a little bit about what's really going on. Well, what's really going on is that if you go back to our usual graphs of X and Y, okay, you have been given a point for me where I have 3 units of X and 5 units of Y, which is here, right? The thing that I don't know is I don't know my budget constraint, but I know that my budget constraint goes through those points. So my budget constraint could be here, or my budget constraint could be here, right? You get the point. Right? I don't know what the prices are. And by the way, the prices will also determine the income, okay? Say, for example, the price of X was 2 and the price of Y was 4. What would be my budget constraint? Well, in that case, it would be easy. I'd say income would be equal to 2 times 3 plus 5 times 4. That's 26. And from there, I could draw the budget constraint. I could say, oh, well, if it's my income is 26, what's the maximum amount of X that I can afford? it would be 26 divided by 2 would be 13. Okay, so maybe I'd go here and I'd say, okay, 13. Maybe if I make this in twos, 4, 6, 8, 10, 12, 13. 13 is the maximum amount of x that I can afford. So right in the middle point there. What about y? Y is priced at 4. So that would be 6.5. 1, 2, 3, 4, 5, 6.5. Right? And if I join them together, note that my point here, it's no longer captured because I actually changed the units of measure. Okay, I changed the units of measure. Now that I've made everything in twos, note that my 3 units here is still there. Okay, and my 5 units um, is still there because I actually didn't change the units here. Okay, so note as expected, um, with this set of prices, which were arbitrary, I'm able to come up with a budget constraint. Now, what happens if I double the prices? Okay, so let's say the prices are 4 and 8. Well, then my income is going to be double because I'm going to have an extra 2 here, an extra 2 here. So my income is going to be 52. But what about my budget constraint? What's the maximum amount of X's that I can afford? Well, 52 divided by 4 is still 13. Okay, 52 divided by 8, it's still that 6.5 that I was talking about. So actually, let me delete what I had before so you can actually just focus on that graph here. So this point here is my endowment. If you give me some arbitrary set of prices, I will be able to draw my budget constraint. And if you go back to the videos that we've been discussing, you should be able to come up and find my optimal choice, right? So in this particular case, let's say, for example, if they're 2 and 4, I can plug them into here and say, well, py over px is 2. So this is going to be 2 times 5, 10, plus 5, 13, divided by 2 will be 6.5. Okay, so I could say that if this is the set of prices, my X star is going to be 6.5. Okay, and then my Y star, I'm still going to spend half of my income on Y. So my Y star would be a half of 26 divided by 4. So that would be 13 divided by 4. So that is 6.5 divided by 2. Um, and that is 3.75. Okay. So if you were to give me those prices, I could then figure out exactly what my optimal choice is, and it is to have a 6.5 units, so somewhere here. Okay. And 3.75 would be my Y. Right? If I 3.25, sorry, 3.25, right? Which kind of makes sense, right? 3.25 sounds about right over there. So that would be my optimal point where it would be tangent to my indifference curve. Now, so I juggled a lot here with just some numbers. Um, and what I want you to kind of realize is that I started off with this idea of what is an equilibrium, and I said a pair of prices, initial endowment, final allocation, such that the market clears, so demand is equal to supply, and both agents maximize utility. And I went through this roundabout um, just to show you that I could come up with some arbitrary, uh, for a given endowment, I can come up with some arbitrary prices, which I did here. Okay. And I could come up with some final allocation for me. Of course, this will imply what the final allocation for the other person should be if the markets were to clear. Okay, so if the markets were to clear, there's only how many units of X there? There's only 14 units. So if I want 4.5, it better be the case that Ben's optimal choice is 3.5 and 7.5. Okay. So it better be the case that Ben wants the remaining 7.5 and wants so in an optimal way. Right? I made up this number, so it's unlikely, but you can try as a homework. You can say, okay, I now know how to work with Cobb-Douglas if you've listened to the previous videos. I want to find out if I find an x of 7.5. Okay. And the y, of course, should be the remaining 6.75, right? And if, of course, if any of those numbers don't match, then you have not come up with an equilibrium price. So the equilibrium price is not part, or these two prices are not part of the equilibrium given this initial endowments. Okay, so in short, I've given you a taste of what an equilibrium is, or what it isn't an equilibrium, or how to check whether something is or it isn't an equilibrium. And in the next video, I'll work through this example to actually find the equilibrium. I hope you're finding this helpful. I look forward to seeing you on the next one.